Right. Today we're going to talk about pH, and pH is a way of measuring it. It's a quantitative, it means a quantity, a number, to measure the concentration of the hydronium ions. Okay, pH actually stands for potential of hydrogen. That's why the H is capitalized and the P isn't. So you're just like, sometimes I used to think, what? Well, it makes perfect sense now because the H stands for hydrogen. So if you're looking at a solution, the concentration of the H3O, the water plus one hydrogen, determines if it's an acid. The more it has, the more acidic it is. If it has more hydroxide, then it's more basic. The weird thing about it is it's based on the quantity. So, and it's a small amount. It's like 1 times 10 to the negative, 2 or something like that. But if I told you, I said, okay, the hydronium concentration is 4.7 times 10 to the negative eighth. Is that an acid or a base? So what they did was they took these amounts, these concentrations, and they took the logarithm of them so that it was a number from 0 to 14. So if I say the pH is 8, you can say, oh, that's a base. Because for pH, 0 to 7 is an acid, above 7 is a base, and if you're right at 7, that's neutral. Okay? So when you're talking about pH, you're talking about the number or the amount of hydronium ions. Okay? And again, like I said, if the pH is less than 7, it tells you it's an acid. If it's greater than 7, it's a base, or sometimes you'll hear alkali. Okay? And if it's right at 7, it's neutral. Okay, so the closer it is to 7, the kind of the weaker the acid and the base are. The farther they're away from 7, like, if you have an acid with a pH of 2, that's a much stronger acid than one of 6. The same with base. If you have one of 14, it's much stronger than one of, 8. So the pH scale gives us an indication of basically the strength. Okay. Your blood and your intercellular fluids, in other words, like your lymph and stuff like that, they have a pH between 7.35 and 7.45. So we're a little bit basic. So if you ever watch shows where they wipe up the blood and they put the little stuff on it and it turns pink, they're actually using an indicator that turns pink in the presence of a base because our blood is basic. Okay. So if you have a pH above this range, okay, if you were, let's say your blood pH is 7.7, okay, you could be in what they call alkalosis. And if you're below, like if you're in the 6 point something range, you have acidosis. Okay, both of these can occur. Acidosis can occur most likely because of you're diabetic, but both of them are life-threatening. Your body doesn't like to be in either of those. It wants to be 7.35 to 7.45 in that range. And if it's not in that range, you're going to have some issues because of it. Because basically your organs are not going to be happy if they have stuff running through them. If you have acid running through your veins, it's not good for anybody. Okay. So pH, we talked about water before. Remember, water we said is amphoteric and it can act like an acid or a base depending on what you react it with. Okay, so even pure water, if you believe it, if you had like distilled water, still gets some of its ions to react, even though there's nothing in it. So water, they say, self-ionizes. It'll break down into its ions. It'll produce hydroxide and hydronium. Okay, so you have your two water. In this one, we'll say, hey, go ahead, take this. So you become hydronium, and then what's left is hydroxide. And this happens naturally in water. Now, if you add something that makes more of this happen, you've got yourself a base. If you add something that makes more of this happen, you've got yourself an acid. And actually, as water sits, as distilled water sits, it will actually be a little bit acidic. Okay? Like, let's say you collect rainwater. Now, you would think rainwater, because it's condensation, pure water, you would think its pH would be at 7, but it's not. It's more like 6. And the reason for that is it absorbs carbon dioxide from the air and produces carboxylic acid. It's not a strong acid, but still lowers the pH a little bit. So it's hard to get stuff at neutral. Okay, so water auto ionizes. Just let it sit and it'll still break down into those ions. Okay, so in pure water, though, if you're looking at the concentration, if you've got distilled water, the concentration of hydronium, HO, or OH, I should say it in the right order, and hydronium and hydroxide, H3O is hydronium, OH is hydroxide. Their concentration is 1 times 10 to the negative 7. They both equal each other, and that's why the pH is 7. Okay? Now, if you want to figure out, let's say you know one of them. Let's say you know the hydronium is 2.5 times 10 to the negative fourth, and you want to find the hydroxide. One thing to always remember is the two of them equal 1 times 10 to the negative 14th. Okay? Whenever you have your hydroxide and hydronium, the two of them, their two concentrations multiplied together, always equal this. So if you know one, you can find the other, but just by dividing. Okay? So if acid is added to water, and the hydroxide, and you want to find, let's say, the hydroxide concentration will drop because you're adding, and hydronium will increase. So if you do this, if you add acid to your water, this is going to get larger, this is going to get smaller, but the two of them together will always equal this. Okay? So that relationship makes it possible because it's always, the two of them always equal 1 times 10 to the negative 14th. If you know one, you can always find the other. Okay? And again, all you have to do to do this, here's an example. Okay, we have the concentration. We want to know what the hydroxide concentration is if the H3O is 2.5 times 10 to the negative 9th. Okay, all you have to do is remember the two of them equal that, so you just divide. Okay, I take 1 times 10 to the negative 14th divided by what I know, the H3O. And so that's going to give me the OH. Now remember, when you take 1 divided by 2.5, it is not 2.5. It's 1 divided by 2.5, not 2.5 divided by 1. Okay, so when you take 1 divided by 2.5, you get 0.4. And then you subtract your exponents. 14 minus 9 is minus 5. I can't leave it this way, you guys, because this is not proper scientific notation. So I move it over 1, and I get 4. Because I made this number bigger, I make this number smaller. It becomes negative 6. So 4.0 times 10 to the negative 6, that is the concentration of the OH. And if you took this and multiplied these two together, you would get this. So anytime you know one, you can always find the other by taking this and dividing. Okay? Okay, so again, it's hard when you have these big numbers, or actually small numbers, to tell if it's an acid or base just by looking at, that. So to avoid the scientific notation, they came up with the pH scale. And again, pH stands for potential hydrogen. And what it means is you calculate the hydronium ion concentration. You use the pH, or pH is calculated from the hydronium ion, because hydronium is what is an acid, what determines if it's an acid or not, right? So pH comes from the hydronium. There's another one called pOH that comes from the hydroxide, okay? And what you do is you take the log of H3O. And again, the negative is out here because if you do this, you'll find out you have a negative number. And they didn't want pH to be a negative number. So if you take the log of whatever the H3O is, you're going to get negative something. Then you just drop the negative and you'll have your pH. Okay, it's based on logarithm scales. Okay, so a change in one pH unit is tenfold. So if you go from 5 to 6, you think you're increasing by 1. No, you're increasing by 10. If you go from like 2 to 4, you're not increasing by 2, you're increasing by 100. So it's 10, 100, 1,000, and so on. Okay? So if a pH of your blood changes by more than 1/10 of a pH unit, it can be fatal. So, and you'll see people, they usually test for like their blood sugar and other things, but they can test for their pH. If your pH of your blood is too low or too high, it's dangerous. Okay? All right. So if the pH of a solution, or the hydronium ions of a solution is 2.63 times 10 to the negative 11th, and I want to know what the pH is. Okay? Again, pH is going to tell me whether it's an acid or a base, and I could figure it out from here, but it's just easier to do this. So remember, pH equals negative the log of the H3O. So basically, take 2.63 times 10 to the negative 11th and put it in your calculator and push log. Okay? You can do it if you don't have a fancy calculator, which you can do. The longer way to do it, and the way I used to have to do it before we had fancy calculators, we take the log of 2.63. We actually had a table that we looked it up on. Or you can go 2.63 log and it'll give you a number. And then the log of any number to the, it's 10 to the negative 11th, so its log is 11. Whatever power it is, that's its log. So you can just subtract those. But thank goodness, most of the time we have calculators that we can just go log of 2.63 times 10 to the negative 11. But again, if you don't have one, you can just take, because the log of 2.63 is negative 4.2, and then subtract 11. And you, remember I said it's negative numbers, but you drop the negative. Okay, this is the long way of doing it. And again, this is the way we used to have to do it. We actually had to look up 2.63 in a table and get the 0.42 and subtract. But fortunately, we have calculators, and all we have to do is go, oh, 2.63 negative 11, and it tells me it is negative 10.58, or drop the negative. So it works out the same. If you have a graphing calculator, I think you have to put log and then the number in. If you have one like this, you put the number in, then log. You'll figure it out, whichever calculator you have, okay? So that's pretty simple. All right, drop the negative 10.58. So again, the easiest way to do this is just take the log of this number and you'll get this. And again, it's a negative, drop the negative. If you don't have that, you can break it down and find the log of this number and subtract it from 11, because, you know, I'm using this, breaking it down into its two numbers. You get the same thing, but this way is much easier. I'm just showing you how we used to do it old school, okay? You're all laughing at me like, we don't have to do that. We have calculators. Okay, so pH, what can we learn about pH? We know that the value that we want inside our body is 7.35 to 7.45. Not quite neutral, a little bit basic, okay? If we change that pH, it disrupts the cell function, okay? And what it does is it takes the functional groups that we have in our body and it can switch them from neutral to ionized forms. And if you start getting ions where you're not supposed to get ions, again, then you're going to get more changes in the pH, and it's just going to cascade, and you're going to end up with some serious issues. And here's 3 of them that they show. Carboxylic acid, we talked about that when we did the organic, and you can see what happens. It loses a hydrogen. Here's phosphate, and this is in our, you guys, this is in your DNA. You definitely don't want to mess with that. Again, lose a hydrogen, or amine group, which is, these are, you'll find a lot in your proteins, okay? You just don't want to mess with those. Now this reverses, now you add a hydrogen, so now this is going to become a base, okay? Oh wait, yeah, this was a base and it becomes an acid, sorry, excuse me. So again, whenever you change that, you're going to have this cascading effect and it's going to get worse and worse. So it needs to be corrected immediately, or, you know, it's going to cause some serious problems, even could cause death, okay? Again, when you change the pH, you cause essential biological reactions that won't take place anymore. And, you know, you need your proteins, you need your DNA, you know, those things are really important, right? Okay, so what happens when you put an acid and a base together? Okay, you can take a really, really nasty acid and a really, really nasty base, put them together, and you get salt and water. It's amazing. It's really easy to do. Especially, again, if they're strong acids and bases, remember they completely ionize. So they will complete the reaction and produce, here's sodium hydroxide. Strongest base, no, it's called lye. Its pH is like 14. Hydrochloric acid, very strong acid. Its pH is down in the 0 to 1 range. Put the two of them together, you get the Na and the Cl form salt and water. The H and the OH form water. So from these two, you put them in the right amounts. It's called titration. You put them in the right amounts and you get salt and water. And whenever we do a lab with acids, I do this. I neutralize them because I can't just pour them down the drain. That's not very, you know, environmentally sound. So I will neutralize them. I'll put, you know, if I have an acid, I'll put base with it until it gets to a neutral. And it's really easy to tell if it's neutral. You just put them together until the pH meter reads 7. Okay? Okay. So again, in this reaction, the sodium and the chlorine are what they call spectator ions. You might not have heard that before. Some of you guys have had some chemistry where you do it. Basically, a spectator ion is one that's not really involved in the reaction. It's the same on both sides. So really what's happening here is that OH and the H are forming water. Those are your big, that's really what happens in a neutralization reaction. These two guys form a salt. And then this guy and this guy, the hydrogen and the hydroxide, form your water. So this is really what happens in a neutralization reaction. Oh, we're almost out of time here. What do we got here? Try to get through this slide. Okay, bases that contain carbon or hydrogen carbonate, which is CO3, when they react with acids, they become carbonic acid. And this is what I was talking about with rainwater that can happen. Okay, carbonic acid isn't a very strong acid, and it's unstable. So it'll break down into water and carbon dioxide. Okay, And if you bubble something, that's a type of reaction. And I'm running out of time. So I'm going to quit here and I'll go back to the slide when I do the next part.